Medical supply system comprises cylinders and pipelines, as explained in the introductory video of this playlist. In this video, we will delve deeper into the central supply system or piped gas system. The central supply is a medical gas distribution system that provides a safe and convenient delivery of medical gases, such as oxygen and nitrous oxide, medical air, and vacuum to hospital facilities through a network of central supply pipelines originating from medical gas supply sources. The system is equipped with a comprehensive color coding system and audio-visual monitoring to ensure the detection of leaks and constant pressure monitoring. The centralized supply system offers several advantages over cylinders. Firstly, it eliminates both visual disturbances and the noise associated with unsightly cylinders at the bedside. Sterile areas are protected from potential contamination caused by the movement of cylinders. The system's main advantage over cylinders is the uninterrupted supply of gases, while also reducing transportation costs and the labor efforts required for transportation. Space utilization is optimized, reducing facility overcrowding. Furthermore, the system centralizes gas distribution, eliminating the need for individual pressure regulators and avoiding the wastage of residual gas in the cylinder. The medical gas pipeline is a complex system, with a range of gases that may not be visually identifiable. Properly labeling the pipeline is crucial due to the critical nature of their usage, as using the wrong gas for a specific function can lead to fatal errors during patient treatment. Additionally, coding the pipes is essential to facilitate planning, installation, and maintenance. The color coding system adheres to cylinder codes. In the international standard, oxygen pipes are designated as white, while in the US standard, they are green. Carbon dioxide is represented as gray, nitrous oxide as blue, helium as brown, and nitrogen as black in both coding systems. Medical air is indicated by white and black internationally and by yellow in accordance with the US standard. The suction pipes or vacuum is coded yellow and white in international and US standard respectively. Waste anesthesia gas disposal is coded purple by both systems. Piped medical gas and vacuum, abbreviated as PMGV, is a system in which gases are delivered from central supply points to various locations within a hospital at pressures exceeding 400 kilopascals, 50 to 55 psi, or approximately 4 bar, 3000 millimeters of mercury. The conversion of these units was discussed in the basic physics section of this playlist, specifically in the cylinder section. Components of the PMGV system include central supply points such as cylinder banks or manifolds, or liquid oxygen storage tanks located separately in manifold room. Pipelines of varying sizes with their corresponding valves and monitors, pressure regulators and alarms are located throughout the supply system. The terminal gas outlets for final gas delivery is located in ward, operation theater, ICU, and other facilities. A cylinder manifold is a system of large cylinders interconnected in series using pipes and valves, designed to supply gas through a pipeline system. Typically, the manifold consists of two-sided cylinder banks, and the number of cylinders connected can vary, ranging from 2 banks of 2 cylinders each to 2 banks of 20 cylinders each, based on facility requirements. It may also incorporate a liquid oxygen storage tank for continuous supply to the cylinder banks and an additional manifold bank for emergency situations. The manifold is equipped with manual or automatic changeover systems between full and empty banks, and a low-pressure alarm signals when it's time to switch cylinders or the manifold rack facilitated by a shut-off valve. Check valves ensure unidirectional gas flow through the manifold, while regulators maintain pressure at the working level. For added safety, a relief valve activates in case of regulator failure or high pressure, protecting the user's equipment from damage. The pipeline network is constructed using copper tubes and comprises various types of pipelines. At its core are the main lines, serving as central pipes that establish connections from the gas source to either riser or branch lines. These main lines form the primary framework of the system, facilitating the initial transport of gas. Connected to the main lines are the risers, vertical pipes that create links between the main lines and branch lines at different levels. The risers play a pivotal role in the vertical distribution of gas. Further extending from the risers are the branch lines, delivering gas to specific rooms or designated areas. These branch lines play a crucial role in the comprehensive network, ensuring the targeted and efficient delivery of gas to its intended destinations. In this hierarchical arrangement, main lines, risers, and branch lines collectively form a network optimized for the distribution of gas within the pipeline system. Pipeline systems have valves installed at various levels, including pressure relief valves, shut-off valves, and check valves. For effective operation, each central supply system requires a pressure relief valve set 50% above normal line pressure located between the pressure regulator and the shut-off valves to prevent pressure buildup. The valve should close automatically when the excess pressure has been relieved. Shut-off valves, divided into manual and service types, enable isolation of piping system for troubleshooting and maintenance without whole system shutdown. Manual or zone shut-off valves must be installed in locations that are visible and accessible at all times. These valves are typically housed in boxes with breakable or removable windows. Each valve should be clearly marked to indicate its function, the type of gas it controls, the specific area it oversees, and a cautionary note emphasizing that it should only be closed in emergency situations. Service shut-off valves, intended for authorized personnel, are secured to prevent accidental closing and strategically located for accessibility in accidental activation. A main shut-off valve is essential at the main supply line entry, while each riser requires one at the connection to the main line. Each branch line must also have a service shut-off valve for maintenance purpose. Check valves ensure one-way gas flow from the central source to the terminal outlet. For the safe and smooth operation of a medical gas pipeline system, a warning and alarm system is vital. This system uses visual indicators to show normal function and gives both visual and audible warnings in abnormal conditions. It comprises master and local alarms. The master or central alarm panel is located close to the medical gas supply source, such as the cylinder manifold or liquid oxygen storage tank. Area or local alarms, as the name implies, are located peripherally in wards, operation theaters, and ICUs. Central alarms monitor supply source functions like cylinder replacement, main supply levels, reserve supply activation, and mainline pressure deviations on alarm panels or a computerized system. Medical gas engineers keep a close eye on these alarms. Area alarms monitor pressure in the pipeline, indicated on a locally mounted indicator panel. These alarms notifies end users on any pressure change in their workplace. Medical terminal units serve as the final delivery points within medical gas piping systems, facilitating quick connections to the system while enabling single-handed insertion and removal of the medical gas probe. They are easily identifiable through color codes and gas labels corresponding to the pipeline color. These units consist of several essential components. The base block forms the connecting part to the pipeline distribution system, functioning as an anchor point for other elements. Additionally, the flush box secures the terminal unit to various surfaces such as walls or ceilings during installation. The secondary valve, along with its retainer, acts as a backup, providing shut-off functionality and serving as a maintenance valve. It activates when the primary valve is removed for cleaning or servicing purposes. The primary valve operates as an automatic shut-off valve and primary check valve, allowing gas flow upon insertion of a male probe and automatically closing when disconnected. Lastly, the secondary fix holds together the valves of the terminal unit, with gas labels imprinted on the label panel, while the entire unit is covered and sealed by the flush fascia. Terminal unit outlets can be mounted on either the wall or the ceiling. There are various types of installations for terminal gas outlets available, such as flush fitting units, surface fitting units, ceiling pendants, and hoses, depending on the facility's requirements. Flush units and surface mounts are commonly found on bed heads in wards and ICUs, while pendants and ceiling hoses are typically utilized in operating theaters. Several safety mechanisms are in place to prevent incorrect gas connections at terminal outlets. These include Schrader's probe and socket connection, the diameter index safety system, and quick connectors. The Schrader probe features a gas-specific index collar with a unique diameter that only fits the corresponding socket for that gas type. For instance, an air hose cannot be connected to an oxygen outlet. The socket is color and shape coded to match the intended probe. The diameter index safety system was developed as a standard for medical gas lines under 200 psi pressure. It is used to connect anesthesia machine hoses to terminal units. This system consists of a body, nipple, and nut combination. Two concentric bores, BB and CC shown in the diagram, on the body fit into two shoulders, MM and NN, on the nipple. Only when these parts align can the threads of the nut and body engage securely. A quick connector is a mechanism that easily connects or disconnects gas-related devices with a single action. It includes a matched pair of gas-specific male and female parts, such as pins and holes. These components securely lock together using a spring mechanism, ensuring a tight connection between related parts. Oxygen is supplied at a pressure of 50 to 55 psi from either high-pressure cylinder manifold, liquid oxygen tanks or the combination of both. In areas where a bulk system or high-pressure cylinder manifold is not suitable, oxygen may be supplied by an oxygen concentrator. However, on-site production of oxygen through pressure swing adsorption is still a relatively new technology. Medical air is compressed air supplied by a special air compressor at a pressure of 4 bar. It is also called medical air 4 bar. In smaller facilities, medical air may also be supplied via high-pressure cylinders. Nitrous oxide is supplied by high-pressure cylinders. Some bulk systems exist, but are no longer installed due to environmental concerns. System pressures are around 50 psi. Instrument air powers surgical tools and is produced on-site using an air compressor. Instrument air is now a popular substitute for nitrogen, operating at pressures around 170 psi. The medical vacuum system in hospitals aids suction equipment by utilizing vacuum pump systems that exhaust to the atmosphere. While vacuum levels may vary along the pipeline, they are typically maintained at around -75 kilopascals or -560 mm of mercury. Waste anesthetic gas disposal or scavenging systems is used in hospital anesthesia evacuation procedures. Although it is similar to a medical vacuum system, scavenging systems do not need to be as powerful as medical vacuum systems, and can be maintained around -50 to -65 kilopascals.